Good morning, sir. Myself Joydev from EC Department, third year. Today I will be explaining pulse code modulation or PCM. Before we dive into the details of PCM, let us first know about sampling and quantization. Here, sampling theorem. Sampling theorem means if a signal is band limited to a maximum frequency, means it has no frequency component higher than, then it can be completely disconstructed if it is sampled at a rate that is at least twice the maximum frequency. Means fs need to be greater than equal to 2 of fm. Here fm is highest frequency component. Then let us know about quantization. Quantization, once the signal is sampled, means after processing through the sampler, once each sample's amplitude can still take infinitely many values, but in PCM we must represent the samples in digital form. So we approximate each sample to the nearest fixed level. This process is called quantization. Here we can see from the graph that there are two types of quantization. One is mid-thread, another is mid-rise. In mid-thread quantization, where 0 lies in middle of a quantization interval, and in mid-rise, where 0 lies on the boundary between two intervals. Okay. Then quantization introduce an error called quantization noise, because the original value is replaced with the nearest available level. Okay, then let us proceed with PCM, means quantization process. First it process through a low pass filter to limit the bandwidth, as we see from the block diagram of PCM. Then it goes to the sampler, which samples the signal at Nyquist rate. Then the quantizer then approximate is sampled to nearest level. Next, the encoder converts these quantized values into binary code. Then we can see the binary output of a analog message signal. Then let us know about transmission bandwidth in PCM. Let's consider that the quantizer uses binary digits to represent each sample. Then number of bits per sample will be V. Number of bits of sample will be V, and number of samples per second will be f of s. Then number of bits per second will be V into f of s bit per second. Means the signaling rate of a signal which has V number of bits per sample and fs Nyquist rate, their signaling rate will be V into fs. Then the bandwidth needed for PCM transmission will be given by half of the signaling rate, means 1/2 into VFS. Then let us talk about quantization noise and SNR in PCM. Because of quantization, there are some error introduced in signal. This error is called quantization error. We have defined quantization error as psi equal to xq nts minus x of nts, and then let an input x of nts be continuous amplitude in the range of minus x max to x max. Then the amplitude range will be 2x max. If we divided the amplitude range into q levels of quantization, then step size sigma is given as sigma equal to 2x max by q. Then let us approximate the step size is very small to distribute as a uniform distribution. Then the distribution ex max will be del by 2, which is range between minus del by 2 to plus del by 2. Then let us talk about signal to quantization noise ratio, which is known as SQNR. The SQNR defined as signal power by noise power. The noise power is given as a mean value of RMS value of noise by resistance. Here noise power is mean square value of noise voltage. Since noise is defined by random variable psi sigma e, and PDF f of e its mean square value is given as e of its square. Then by solving the integration, we get that the noise power will be sigma square by 12 when we normalize the resistance and take the resistance value equal to 1. Then the number of bits is v and quantization level is q. Then q equal to 2 to the power v. Then SQNR will be p by del square by 12. Then putting the value of del, we get that SQNR equal to 3p by x max to the power square into 2 into to the power 2v. Then if we normalize x max equal to 1, and also the destination single power is normalized, which is p less than equal to 1, then SQNR less than equal to 3 into to the power 2v. Then we expressing SQNR in decibel by taking 10 log 10 of SQNR. The value will be SQNR in dB is less than equal to 4.8 plus 6V, where V is bits per sample. Thank you.